Have you noticed how powerful earthquakes seem to be appearing around the Pacific more often? In just a matter of days, another magnitude 6.5 earthquake struck near Papua New Guinea, one of the most active seismic regions on Earth. At the same time, moderate earthquakes were recorded near Japan, Vanuatu, New Caledonia, Chile, and the Philippines. It immediately raised one question across social media. Is the Pacific Ring of Fire waking up again? Stay with me until the end, because the most surprising part is not where these earthquakes happened. It is what scientists are carefully watching beneath the surface. The Pacific Ring of Fire stretches for about 40,000 kilometers around the Pacific Ocean. It is not a single fault. Instead, it is a massive network of tectonic plate boundaries surrounding the ocean basin. Nearly 90% of the world's earthquakes occur somewhere along this enormous belt. Hundreds of active volcanoes are also located here. Because of that, even a normal week can produce dozens of noticeable earthquakes across different countries. But this week caught people's attention for another reason. On July 13th, a magnitude 6.5 earthquake struck near the Lorengau region of Papua New Guinea. According to the United States Geological Survey, the earthquake occurred at a depth of nearly 48 kilometers. Fortunately, there were no immediate reports of catastrophic damage or widespread casualties. Still, the event reminded millions of people that this region is constantly under enormous tectonic pressure. Around the same period, additional earthquakes were reported near Japan, Vanuatu, New Caledonia, Ecuador, Chile, and the Philippines. None of these events alone proves that something unusual is happening. Earthquakes often occur independently along different plate boundaries. However, when people see multiple events happening across the Ring of Fire within days, it naturally creates concern. So, does one earthquake trigger another thousands of kilometers away? The answer is more complicated than many headlines suggest. Scientists explain that the Ring of Fire is made up of several different tectonic plates. These include the Pacific Plate, the Philippine Sea Plate, the Nazca Plate, the Cocos Plate, and several others. Each boundary behaves differently. Some plates slide past each other, others collide. Some sink beneath neighboring plates in a process called subduction. Subduction is one of the most powerful geological processes on Earth. Imagine pushing one giant slab of rock beneath another. That movement happens extremely slowly, often only a few centimeters each year. But stress builds continuously. Eventually, the rocks can no longer hold the pressure. When they suddenly slip, enormous amounts of energy are released in just seconds. That energy travels through the Earth as seismic waves. We experience those waves as an earthquake. This does not mean every earthquake is connected. In fact, seismologists usually caution against assuming that several earthquakes automatically signal one giant event. Most earthquakes happen because stress is released locally, not because an entire ocean basin suddenly becomes unstable. That is why experts rely on long-term seismic data instead of dramatic patterns seen over only a few days. Even so, monitoring agencies never ignore clusters of activity. Every new earthquake provides valuable information about stress distribution inside Earth's crust. Advanced instruments measure tiny changes in ground motion, fault behavior, and aftershock patterns. These observations help scientists improve hazard assessments, although predicting the exact time and place of a future major earthquake remains impossible with today's science. And yet, there is one detail that has researchers paying particularly close attention. Because the strongest warning sign may not be the earthquakes themselves. One large earthquake is expected. Even several moderate earthquakes over a few days can be completely normal inside the Ring of Fire. But when seismic instruments begin detecting unusual clusters, changes in aftershock behavior, or subtle deformation of the Earth's crust, researchers pay much closer attention. These signals do not predict a major earthquake. They simply help scientists understand how stress is moving through complex fault systems. History shows why this careful monitoring matters. On March 11, 2011, a magnitude 9.0 earthquake struck off the coast of northeastern Japan. The violent shaking lasted for several minutes before a devastating tsunami crossed the Pacific. More than 18,000 people lost their lives or remain missing. Entire towns disappeared within minutes. Yet even after decades of research, scientists still could not predict the exact day or hour that disaster would occur. Another reminder came in 2004, when the Indian Ocean earthquake generated one of the deadliest tsunamis in recorded history. That catastrophe transformed global tsunami warning systems and demonstrated why continuous monitoring is just as important as emergency preparation. Today, the Pacific Ring of Fire remains the most seismically active region on Earth. Around 90% of the world's earthquakes occur somewhere along this enormous belt, stretching from New Zealand to Indonesia, Japan, Alaska, the western coast of North America, and down to Chile. That sounds alarming, but it is also completely normal from a geological perspective. The Ring of Fire is where multiple tectonic plates constantly collide, slide, and sink beneath one another. So what should we expect next? The honest answer is that nobody knows exactly where the next major earthquake will happen. The United States Geological Survey and other monitoring agencies continue tracking thousands of earthquakes every month. Every new event adds valuable data to improve hazard maps, building standards, and tsunami warning systems. Scientists can estimate long-term probabilities for certain regions, but they cannot accurately predict the exact location, magnitude, or timing of the next destructive earthquake with today's technology. That is why every earthquake reported this week deserves attention, but not panic. Recent moderate earthquakes near Japan, Indonesia, the Philippines, Papua New Guinea, Alaska, and parts of South America demonstrate that the Ring of Fire is doing what it has done for millions of years. These events do not automatically mean that a massive megaquake is about to happen. In fact, USGS repeatedly warns against assuming that several earthquakes over a short period indicate a larger event is imminent. Each earthquake must be evaluated on its own geological conditions. The real lesson is surprisingly simple. Nature does not follow social media trends. It follows physics. Deep beneath the Pacific Ocean, tectonic plates continue moving only a few centimeters each year. That motion is almost impossible to notice in everyday life. Yet over decades and centuries, those tiny movements reshape continents, create mountains, fuel volcanoes, and occasionally release unimaginable amounts of energy in a matter of seconds. For now, scientists are watching. The instruments are running. Satellites continue measuring ground deformation. Seismic stations continue recording every vibration, no matter how small. And while no one can say when the next great earthquake will arrive, every new piece of data helps researchers better understand one of Earth's most powerful natural systems. We'll continue following every major development across the Pacific Ring of Fire and explain the science behind the headlines, without exaggeration and without fear. If you enjoy evidence-based coverage of earthquakes, volcanoes, and extreme natural events, subscribe to the channel and stay with us. Because the next important discovery may begin with a signal too small for anyone else to notice.